UML class diagrams are presented by Samantha, John, Peter, and Zach. UML class diagram stands for Unified Modeling Language. That's UML. And there are two basic categories of diagrams. There's the structure diagrams and behavioral diagrams. UML class diagrams are an example of a structure diagram under this category. Its purpose is to show the types being modeled within the system. It's an important industry standard language for modeling object-oriented systems, and a UML class diagram provides a visually expressive and intuitive model of the systems. The UML representation of a class is a rectangle containing 3 compartments stacked vertically. The top consists of the class's name, the middle is the class's attributes, and the bottom is the methods and operations. The notations and syntax are exemplified on the left, as well as under the bullet points. When drawing a class element on a class diagram, you must use the top compartment, but the bottom 2 are optional. You can indicate access privileges for both the attributes and the methods, as indicated below. A plus sign indicates public, a hashtag indicates that it's protected, a tilde indicates it as a package, a dash indicates that it's private, and a backslash consists of it being derived.
Different classes in a UML diagram can show relationships using different lines. In a UML diagram, you can have composition relationships, aggregation relationships, inheritance, nested classes, associations, or dependencies. In the following slides, we'll go over these different types of relationships. Composition relationships are denoted by a black square. They are used when a relationship is a has-a relationship, where one class is a part of another class. Composition is used when one class is inside of the other class, usually as a member variable. When the parent class is destroyed, all the other classes that are member variables will also be destroyed. Aggregation is similar. However, in an aggregation relationship, the has-a relationship is less strict. So when the parent class is destroyed, the other object or class can still remain intact. Inheritance is a relationship, where one class is of another class. Let's go over some examples. Let's say you have a house class. A composition relationship might be the different bedrooms in a house. The kitchen, the bedroom, the living room are all inside the house. Whereas a shed might be part of the class of house, but isn't necessarily inside the house, so it can stand by itself. That would be aggregation. With inheritance, the different bedrooms could all be rooms and inherit the room class. Nested classes are denoted with a circle with a plus inside. This means that one class is defined and built inside the other class. This is similar to aggregation and composition. However, the other class is not used anywhere else. It is only inside that one class. Therefore, it's a nested class. Association is used when two classes are aware of each other, but don't necessarily have each other inside of them. So they might be two classes that talk with each other, but don't really own one another. And dependency is simply a dotted arrow.
There are 3 relationship indicators that we use when using UML class diagrams. The first is multiplicity. This shows how many of each class are used in comparison with each other's. These are denoted by the 1 on the left side in the diagram. On the right side, you can see the table that shows the indicator and the meaning. So the first is 0 to 1, meaning that there could be 0 of this class up to 1 of them. 1 only means that there is 1 and only 1 of this particular class. 0 to an asterisk or just an asterisk means that there's 0, or there can be as many as are needed. The next is one or more, meaning that there has to be at least one or as many as we need. And then the last is an indicated amount, meaning that there can be, in this example, as little as 5 and as many as 15, but this can be changed. The second is a name. This denotes the relationship of the line between the two classes. For instance, in the diagram on the left, it says Class A contains Class B. This means that Class B is contained within Class A. And then the third is navigability. This is noted by direction. This means that it flows from Class A to Class B. Now let's look at a demonstration. As you can see here, we have the student model, student controller, and student view. The student model contains all the attributes of the student class. The controller contains all of the operations that the class may perform, and the student view contains some operations to update the view. As you can see, navigability shows that they flow to the right, and there's a one-to-one relationship between each of the different classes.
Okay, now moving on to the upsides of using a UML class diagram. First, it shows the static structure of the classifiers of a system. So it shows all the fields, methods, and connections between the classes. So it's a really good big picture kind of diagram that helps us know what's going to be contained in the classes as the methods and the connections between the classes and how the inheritance works and things like that. So it makes it really useful for providing a good overall view of what the system will work as. Next, it provides the basic notation for other structure diagrams prescribed by the UML. So it helps us have a basic structure of the overall system. Like I said, it's a really good big picture kind of view that we can have. Next, it's good for business analysts can use the class diagrams to model systems from the business perspective. So it's really good and simplistic enough that people from the business side of the company can see, and these can be the stakeholders, and they can see if it meets their needs or not. And they can provide feedback and kind of concerns, and it can be easily handled with that. So it helps them get the big picture of the overall system, and it's simplistic enough for them to understand, but it also provides enough detail so that way they can see if there's any potential concerns. And then next, UML class diagrams are intuitive and understandable to practitioners in the industry. So it's really simple to understand. It's really easy to see and follow the lines to see where connections are made between the classes and how the system will overall work. Moving on to the downside, it's not as a precise analyst tool. It is limited due to the lack of precise semantics and practical analysis techniques. So it's not very specific in what things do. It can miss a lot of information that can be described better in other diagrams. So it's not the best for a more detailed approach to a diagram. And then they also do not offer the precision that is often required when reasoning with software systems. So these include no algorithmic details and no indicators of how a particular behavior is implemented. So we can see the methods and see that an algorithm is getting called, but we won't be able to see what the algorithm actually does. And that can be problematic for this view. If we wanted to see a more detailed approach of how the algorithm works, it would be better done in a different kind of diagram. And then for our recommendations, these class diagrams are great for discovering related data and attributes. It's good at getting a quick picture of the important entities in a system, seeing whether you have too few or many classes, seeing whether the relationships between the objects are too complex, too many in number, or simple enough, and spotting dependencies between one class and object over another. So it's good to see what classes are getting used a lot, what classes aren't, if we don't have enough classes, or if something can be done in another class, it's good for that. And it's also good for getting that quick picture of how the system works. It can be glanced at and understood very quickly. But it's not so great for discovering algorithmic, not data-driven behavior, finding the flow of steps for objects to solve a given problem, and understanding the app's overall control flow, event-driven, web-based, or sequential. So it's not great for discovering those algorithms like we talked about already, and also it doesn't show the flow of how a class solves those problems. So we can't see what classes are called when a certain instance happens in the system. So that's where it kind of has some downfalls. But overall, class diagrams are very good at giving that overall view and showing those relationships and what's contained in those classes very simply. But it gives good detail. And here are our citations for our presentation. And here are some more. And that's all. And here are some of our test questions.